Today class parametric test. Statistical test. Statistical test is two types: parametric test, non-parametric test. Parametric test. Parametric test is a statistical test that makes assumptions about the parameters of the population distribution from which one data is drawn. Application used for quantitative data, continuous variables, used when data are measured or approximate interval. Data should follow normal distribution. Parametric test. T-test, ANOVA, Pearson's or correlation is a test. T-test means two types. T-test for one sample, T-test for two samples. T-test for two samples is two type. First one, unpaired two sample T-test, paired two sample T-test. ANOVA test. ANOVA test is two type: one way ANOVA, two way ANOVA. Student T-test. Developed by Prof. W.S. Gosselt. A T-test compares the difference between two means of different groups to determine whether the difference is statistically significant. One sample T-test. Assumptions: population is normally distributed. Sample is drawn from the population and it should be random. We should know the population mean. Conditions: population standard deviation is not known. Size of sample is small, less than 30. The T-test is: let x1 up to etc. xn be a random sample of size small n as drawn from the normal population with mean mu and variance sigma squared. Null hypothesis H0. Population mean mu is equal to specified value mu naught. Under H0, the test statistic T equal to x bar minus mu divided by s divided root n, where x bar sample mean, mu population mean, s standard deviation, root n number of samples. Two sample T-test. Used when two independent random samples come from the normal populations having unknown or same variance. We test the null hypothesis that the two population means are same, that is mu1 equal to mu2. Assumptions: populations are distributed normally, samples are drawn independently and at random. Conditions: standard deviation in the population are same and not now. Size of sample is small. If two independent samples xi and yi, the sample size is n1 and n2, the two normal population mu1 and mu2 respectively. Null hypothesis H0 such that mu1 equal to mu2. Under H0, test statistic is T equal to modulus of x bar minus y bar divide s root 1 by n1 plus 1 by n2, where x bar is the first sample mean, y bar second sample mean, n1 n2 number of sample 1, number of sample 2, s is sample standard deviation. Paired T-test used when measurement are taken from the same subject before and after some treatment. Assumption: population are distributed normally, samples are drawn independently and at random. Conditions: samples are related with each other, size of samples are small and equal, standard deviation in the population are equal and not known. Null hypothesis H0 such that mu d equal to 0. Under H0, the test statistic paired T-test T equal to modulus of d bar divide s divide root n, where d equal to difference between 1 and 2, d bar average of d, s standard deviation, n sample size. Z-test. Z-test is a statistical test where normal distribution is applied and basically used for dealing with problems relating to large samples when the frequency is greater than or equal to 30. It is used when population standard deviation is known. Assumptions: population is normally distributed, the sample is drawn at random. Conditions: population standard deviation sigma is known, sample size is large, say n greater than 30. Let x1 up to etc. xn be a random sample of size small n from normal population with mean mu and variance sigma squared. Let x bar be the sample mean of sample size small n. Null hypothesis: population mean mu is equal to specified value mu naught H0 such that mu equal to mu naught. Test under H0, test statistic is Z equal to modulus of x bar minus mu naught divide s divide root n. If the calculated value is at less than table value of Z at 5% level of significance, H0 is accepted. Hence, we conclude there is no significant difference between the population mean and one specified value in H0, Pearson's or correlation. Correlation is a technique of investigating the relationship between two quantitative continuous variables. Pearson's correlation coefficient or is the measure of the strength of the association between two variables. Types of correlation. Type of correlation. Correlation coefficient. Perfect positive correlation R equal to +1. Partial positive correlation 0 less than or less than +1. No correlation R equal to 0. Partial negative correlation 0 greater than or greater than -1. Perfect negative correlation R equal to -1. Analysis of variance. ANOVA is a correlation of a statistical methods used to analyze the difference between group means or variance. Compare multiple groups at one time. Developed by R.A. Fisher. ANOVA is two-way. One-way ANOVA, two-way ANOVA, one-way ANOVA. Compare two or more unmatched groups when data are categorized in one factor. Example, comparing a control group with 3 different doses. Comparing the 3 or more employees based on working hours in a company. Two-way ANOVA used to determine the effect of two nominal variables on a continuous outcome variable. Comparing the employee productivity based on working hours and working conditions. Assumptions of ANOVA. The samples are independent and selected randomly. Parent population from which samples are taken is of normal distribution. Various treatment and environmental effects are additive in nature. The experimental errors are distributed normally with mean 0 and variance sigma squared. ANOVA. ANOVA is using F ratio. F equal to variance between sample divide variance within sample. Null hypothesis. H0 all population means are same. If the calculated value greater than F table value, we reject the null hypothesis. If calculated value less than the table value, therefore the null hypothesis is accepted. ANOVA table. Source of variation, sum of square, degrees of freedom, mean squares, F ratio. Treatment sum of square. The degrees of freedom is k minus 1. Mean sum of square. Treatment sum of square divide degrees of freedom. F ratio means treatment mean square divide error mean square. Within samples of groups errors. Error sum of square ESS. Degrees of freedom n minus k. Mean square error sum of square divide degrees of freedom n minus k. Total sum of square TSS. Degrees of freedom is n minus 1.